Hello, I Abhishek Misar welcome you to all on the lecture on divider and multiplication circuit using op amp. In this comprehensive lecture, we will study the another application of operational amplifier. We discuss the following point. First, that is introduction. The second point is analog multiplication using op amp. In this point, we will consider voltage control voltage source method. The fourth point is fourth quadrant multiplier. The fifth point is ideal divider circuit, and the sixth point is analysis of VCC circuit. The last point is conclusion. In the introduction, we will study the principle of analog multiplier. Analog multiplier are the crucial component in electronics circuit, where the multiplication of two signals is required. They find application in various fields, including signal processing, communication system, and control engineering. The fundamental principle behind the analog multiplier lies in modulation of one signal by another, generating an output signal proportional to the product of input signal. The basic operation of the analog multiplier is analog multiplier amplify on the basic principle and operation of analog multiplier is analog multiplier work on the principle of modulation. The amplitude of one input signal, that is called modulating signal, with another input signal, that is called carrier signal. The modulating signal alter the gain of amplifier, which in turn affect the amplitude of carrier signal, producing an output signal proportional to the product of the two input signal. To implement this concept, the analog multiplier often involve using transistor based or operational amplifier basic circuit. Operational amplifier are widely employed due to their high gain, high input impedance and low output impedance. One common configuration is Gilbert cell, which is utilized 4 transistor to achieve multiplication. Another method involved using analog multiplier is integrated circuit, especially designed to perform the multiplication for accurate operation. Analog multiplication using op amp. Here we discuss the application of analog as a multiplier. So, first analog multiplication circuit using operational amplifier. The working principle of this multiplication circuit are it is use operational amplifier, which can be achieved through various circuit configuration. Working principle: analog multiplication using operational amplifier can be achieved through various circuit configuration. One common approach is using the voltage control voltage source method. This method utilizes the inherent characteristic of op amp to create a circuit that multiply two input voltages. Let us explore the working of an analog multiplication circuit using op amp in detail. In this, you see the circuit configuration. Here consider a basic analog multiplier circuit with two input voltage V1 and V2. To be multiply, the circuit use a operational amplifier and several resistor to achieve the multiplication operation. The second is voltage control voltage source configuration. The op amp is configured as voltage control voltage source, where the output voltage V out is proportional to the product of input voltage V 1 and V 2. The working step are described here. The first step is a input stage, where V 1 and V 2 are applied to non-inverting and inverting terminal of the op amp respectively. The feedback network, the op amp's output is connected back to its inverting input terminal through a resistor network. Let RF be the feedback resistor connected from the output to the inverting input. Let R 1 and R 2 be resistor connected in series between the inverting input and ground. The voltage at junction of R 1 and R 2 is V x. The most important concept is virtual short circuit concept. In this concept, due to the high open loop gain of op amp, the voltage at the inverting and non-inverting terminal is V x is virtually shorted. Voltage at inverting terminal V x applying the virtual short circuit concept. The voltage at the inverting terminal V x can be written as V x is equal to R 2 upon R 1 plus R 2 multiplied by V 1, and the next is output voltage V out. Using the feedback resistor R f, the output voltage V out is given by V out is equal to minus R f in the bracket R 2 upon in the bracket R 1 plus R 2 bracket close, and then all the equation is multiplied by V 1 V 2. This equation show that the output voltage is proportional to the product of two input voltage V 1 and V 2. With the proportionality concept, determine the resistor value R f, R 1 and R 2. Now, we discuss the practical consideration. Thus, choice of resistor value and the selection of appropriate op amp are crucial for accurate multiplication. High precision resistor and op amp with low offset voltage are preferred for application. Required precision multiplication. Now, we discuss the application of this analog multiplier. Analog multiplier using op amp find application in modulators, demodulators, signal processing circuit and instrumentation system, where multiplication of analog signal is essential by understanding the principle of circuit. Engineers can design accurate and reliable analog multiplication circuit using operational amplifier for various real world application. Now, we discuss voltage control voltage source method, that is describe VCVS. This voltage control voltage source method is a fundamental technique in the real of operational amplifier. It play a pivotal role in a analog circuit, offering precise control over voltage level. This method harness the unique properties of op amp, employing them as versatile tool for manipulating and modulating signal in various applications. For understanding the VC/Vs concept, the VC/Vs configuration involve utilizing an operational amplifier to create a circuit where the output voltage V out is directly proportional to control voltage, that is VC, and input voltage V in. This method relies on high input impedance and open loop gain of op amp. By varying the control voltage, engineers can effectively control the gain or attenuation of the input signal V in, making the VC/Vs an excellent tool for amplification, modulation and other signal processing tasks. Implementing VC/Vs using op amp. A basic VC/Vs circuit involve an op amp configured in an inverting or non-inverting amplifier configuration. In the inverting VC/Vs, the control voltage source Vc is applied to inverting terminal of the op amp, while the input voltage V in is fed into the non-inverting terminal. The output voltage V out is then amplified or attenuated based on the ratio of resistor in the circuit. In the non-inverting VCS, the control voltage is applied to the non-inverting terminal and the input voltage V in is applied to the inverting terminal. The output voltage V out is amplified or attenuated based on the resistor value in the circuit. The configuration offer a wider range of voltage gain than the inverting VC/Vs. Ideal multiplier circuit using operational amplifier. The ideal multiplier circuit typically employs 4 operational amplifier in a configuration known as Gilbert cell multiplier. The configuration allow precise multiplication of 2 input voltage V 1 and V 2, producing an output voltage V out proportional to V 1 and V 2. The circuit diagram is shown below. In the ideal multiplier circuit using operational amplifier, you can see this circuit diagram, it multiply the 2 voltage. Now, the input stage. In the input stage, we use V 1 and V 2 are fed into the non-inverting terminal of first 2 op amp, that is U 1 A and U 1 B. Similarly, V 1 and V 2 are inverted and fed into the inverting terminal of other 2 op amps, that is U 1 C and U 1 D. Intermediate stage U 1 A and U 1 C amplify V 1 independently, U 1 B and U 1 D amplify V 2 independently. Multiplication stage. The output of U1A and U1C are connected to the inverting input of U1D. The output of U1B and U1D are connected to the inverting input of U1C. V out is obtained from the non-inverting output of U1C. Now, let us discuss the working of this circuit. When V1 is applied to U1A and U1C and V2 to U1B and U1D, the voltage at the junction are V1 and minus V1 for U1A and U1C and V2 and minus V2 for U1B and U1D respectively. U1C amplifies minus V1 multiplied by V2 and U1D amplifies minus V2 multiplied by V1. These amplified signal are then fed to U1B and U1A respectively. U1B amplify V1 multiplied by V2 and the final output is available at non-inverting terminal of U1C, which is V out equal to V1 multiplied by V2. Please note that in this circuit the resistor and feedback networks in the circuit are designed carefully to ensure the desired amplification and proper scaling of the output voltage. Practical circuit may require additional compensation and balancing component to minimize error and enhance accuracy. This ideal multiplier circuit provides a basic for understanding the concept of multiplication using operational amplifier. In real world application, it is crucial to consider components, tolerance, temperature effect and other factor to design accurate and reliable multiplier circuit. For practical consideration and limitation, amplifier based multiplier circuit, operational amplifier based multiplier circuit are indispensable tool in the realm of analog electronics, enabling precise multiplication of signal in various applications. However, like any electronic circuit, these multiplier come with their set of practical consideration and limitation. Understanding these aspects is essential for engineers to design reliable and accurate multiplier circuit. In this case, we will explore the practical consideration and limitation associated with multiplier circuit using operation amplifier. The first important thing is component tolerance. One of the primary practical consideration in designing multiplier circuit is the tolerance of components such as resistor and capacitor. Even a slight deviation from the specified value can introduce error in the output. The mitigate this issue, engineer often resort to precision component which have higher tolerance range. Additionally, calibration techniques can be employed to compensate for component variation and ensure accurate multiplication. The next is temperature effect. Temperature fluctuation can significantly impact the performance of multiplier circuit. The characteristic of operational amplifier, especially their offset voltage and gain, can change with temperature variation. This phenomena can lead to drift in the output, affecting the accuracy of the multiplication. To address temperature effect, designer employ temperature compensated component or incorporate temperature sensor to dynamically adjust the circuit parameter based on temperature change. Power supply rejection ratio. Operation amplifier are susceptible in variation in the power supply voltage. Any noise or fluctuation in power supply can directly affect the output of multiplier circuit. Operational amplifier with high power supply rejection ratio are preferred in application where stable power supply is challenging. PSRR quantifies the ability of the amplifier to reject changes in power supply voltage and is crucial parameter in ensuring the stability of multiplier circuit. The another limitation is bandwidth limitation. Multiplier circuits using operational amplifier have specific bandwidth limitation. Beyond a certain frequency, the circuit performance degrade and accurate multiplication cannot be achieved. Engineers need to consider the application's bandwidth requirement and select operational amplifier with suitable bandwidth capabilities. Techniques such as frequency compensation and careful selection of op-amp model are employed to address bandwidth limitation. The next point is noise and signal integrity. Noise, both inherent to operational amplifier and external, can introduce unwanted fluctuation in the output signal. This is critical consideration, especially in high precision application. Designer implement filtering technique and shielding method to minimize noise interface. Additionally, maintaining good signal integrity by avoiding signal coupling and using proper grounding technique is essential to preserve the accuracy of the multiplier circuit. Next point is input and output impedance matching. Mismatch input and output impedance can lead to signal reflection and loss of power in the circuit. Engineer must carefully design the input and output stage of multiplier circuit to ensure impedance matching. Proper impedance matching not only maximize power transfer, but also minimize the impact of external factors such as transmission line effect on the circuit performance. The next point is saturation and output voltage swing. Operational amplifier have finite output voltage swing capabilities. If the multiplied output exceed this range, the op amp saturate, leading to distorted output signal. Engineers need to ensure that the circuit input signal and gain are within the permissible range to avoid saturation. Additionally, careful consideration of op amp's common mode voltage range is necessary to prevent common mode distortion in the output. Now, we discuss the fourth coordinate multiplier using operational amplifier. The precision is signal processing required. The 4 quadrant multiplier using operational amplifier represent an innovative approach in analog signal processing. It allows for a precise multiplication of two input signal even when they vary in both magnitude and direction. This versatile technique find extensive application in the field of telecommunication, control system and instrumentation. In this way, we will explore the intricacies of 4 quadrant multiplier, shielding light on its working principle, application and advantage. The first point is working principle. A 4 quadrant multiplier enables the multiplication of signal regardless of their polarity. Operational amplifier known for their own high precision and linearity are configured in a specific arrangement to achieve this functionality. The core of this configuration involve utilizing a pair of operational amplifier in a feedback loop. The operational amplifiers are arranged in an analog multiplier configuration, enabling the circuit to handle both positive and negative inputs signal. By carefully adjusting the feedback network, the circuit achieve accurate multiplication across all 4 coordinates of the input signal space. The application in practical scenario. The 4 quadrant multiplier find application in various real world scenario, especially in system where signal modulation, demodulation and control are crucial. On one of its primary application is in amplitude modulation system, where it is used to multiply the modulating signal with the carrier signal. The multiplication process is vital for encoding information onto the carrier wave effectively. Additionally, in frequency mixing application where different frequency need to be combined or modulated, the 4 quadrant multiplier play a pivotal role. It is also employment in practical loop to perform phase and frequency detection tasks accurately. The advantage of 4 quadrant multiplier: accuracy and linearity. The inherent precision of operational amplifier ensure high accuracy and linearity in the multiplication process. The accuracy is essential in application where an even slight deviation can result in significant error. The next is wide dynamic range. 4 quadrant multiplier can handle a wide range of input amplitudes, making them suitable for application where signals can vary substantially in magnitude. The next is flexibility. These multipliers are versatile and can process both AC, DC signal. Their ability to handle signal with varying polarity add to their flexibility, making them adaptable to diverse application. Ideal divider circuit using operational amplifier. Precision in division. Operational amplifier are fundamental components in analog electronics, known for their versatility and accuracy. Known for their versatility and accuracy. Utilization: op-amp engineers have devised various circuit configuration to perform complex mathematical operation, including division. An ideal divider circuit based on op-amp offer precise division of input signal. Finding application in field like instrumentation, control and communication technology. In this lecture, we will explore the principle behind the ideal divider circuit. It is working mechanism, practical consideration and application. The basic principle: the ideal circuit employs operational amplifier in configuration that enable the precise division of two input voltage denoted as V input 1 and V input 2. This circuit essentially compare the magnitude of two input voltage and provide output voltage V out. That is the role of V in and V 2. In conclusion, operational amplifier serve the building block for analog, multiplier and divider, enabling a wide range of application in electronics. By understanding the fundamental principle and practical consideration, engineer can design efficient and reliable analog, multiplier and divider circuit. Thank you for watching this video.